Hello and welcome to my tutorial Hidden Fields for Java High Performance Persistence. My name is Sven and I'm developer advocate for JFrog and specialized for DevSecOps and have a strong history in core Java and core Kotlin projects with industrial background. And I want to explain a little bit my ideas and want to show you some examples of quite cool small projects you can find in the internet for the topic high performance persistence in core Java. First of all, I want to have a persistence bird's eye view just to start with topics and give an idea what my point of view at this moment is, and then some basic questions and thoughts about the fundamental things about persistence and why I'm choosing here these examples I want to show. Small idea what MVCC is, and then I will go through all the candidates I want to present here, and then what you should have in mind if you're dealing with this in terms of DevOps and DevSecOps. Okay, persistence bird's eye view. If you have a look at persistence, mostly you start inside your application with an app model. This app model is a bunch of Java classes. They're connected, you have cycles, maybe you have trees or graphs, but in the end mostly you're dealing with core data structures like maps, queues, lists, arrays and so on. In big applications, or in some applications, you have a cache just to have better performance for your system, and then you have a caching system. A caching system mostly is based on core data structures, and if you're in a bad luck, more or less, you have the first time a mapping, so that your business model must be mapped to fit to the technical needs of this caching product you're using. And don't forget that the cache itself has eviction algorithms and some logic to deal with all this stuff, so you're burning CPU cycles here as well. This is not good for performance. Well, it's CPU cycle, it's consuming CPU cycles, and that's the only thing I want to say here. But maybe you have the first time a model mapping from your app model to the caching model. At some point later, from the cache down to the storage engine, you will have mostly inter-process communication or network-based communication. For example, if you're talking to a traditional database like Postgre. And finally, at this point, you have something like a model mapping. If it is to tables, if it is to key values, or whatever you're using, you have a model mapping as well. So worst case is that from your app model, you're transforming your model 2 times. First to the needs for your cache, and second to the needs of your persistence layer. And this is not nice, but let's see what we can do here. Basic questions about the behavior of data, or the data behavior. So if you're looking at data, you have mostly three parts, or three types of data. One is you're just creating data, writing it once, and you're never touching it. It's just like events from financial data, transaction logs, whatever. So mostly you're just creating this stuff and just writing it down, and you're never touching it. Or you have something like a sliding window, so the data from the last 24 hours is active. You can modify it, you're navigating through, you're dealing with this. And if it is a little bit older, it's just archived. So you're pushing this data to the next level of your persistence layer, and you're not touching it anymore. Or the worst case is all data is hot, so it means the whole data you have, all entities are constantly queried, changed, modified, deleted, added, and so on. So you have to think about this one before you're choosing a persistence layer, because they are a big difference. And if you have to navigate through this data, Mostly the systems have something like SQL or Cypher, if it is Cypher is for graph databases, for example, or maybe you can just go with Java streams on your data. Do you need just all attributes or a subselection of attributes, or during your query you need to calculate data as well, or you have something like a virtual view on your data? So what is in need, and then it will help you to decide what's the right persistence layer for this part of the data you have. Before we will start with candidates I want to show you, I would just have a heads up for the MVCC. MVCC is a multi-version concurrency control. It is a standardized way of dealing with snapshots of your data. Means if you have more than one process that's modifying your data, you need something like snapshot isolation. And there is a core Java implementation. It's a quite old one, but it's available on GitHub. And it has no dependency, so it's really cool Java implementation of this MVCC, and it's on Apache license, so it's a very, let's say, company friendly. And this one is a default implementation of MVCC that you can use if your persistence layer is not dealing with transactions, but you need it. So have a look here, and just as a heads up, you will need some time to understand what it is. You have to read a little bit, but maybe you will need it. So Xodus. Xodus is a product, or it's a project from JetBrains. JetBrains is a company that has here IntelliJ, UTrack and all this. And it's open source and on Apache license. It's free available, so you can use it. And they're using this one inside their own products. They need it for the issue tracker, a document store, and it is a transactional document store. It's exit compliant, so you have transactions. It's non-blocking read and MVCC organized write, this snapshot isolation writes. So this is more or less the key description of it. Interesting, or why I'm choosing this one here as one of the candidates, is it's completely embeddable, so you can run this one inside your Java process, and it's just written in, or it's written in Java and Kotlin. It means you can easily navigate through all of this. So how to start with Xodus? You need the API itself, its dependency, and then one of the three implementations. I will go through all these different implementations and explain a little bit what it is, but you just need these two dependencies, API and one implementation. The very low-level implementation is environments. Environments is just a key value store, and you have two choices. You have the choice with duplicate keys or without duplicate keys, and that means you have a hash map or multi-map, more or less. Everything you have to do is you have to declare a file on your hard disk, so that you know what's the place to store your data. The good thing is, if you're shutting down, just make a copy of this folder and you have a backup. So declare a file where you're pushing your data through, and then everything you're doing, every action is encapsulated inside a transaction. So go to your environment, start a new transaction, and then you can get the entity of a hash map, for example. And what you need is the ID of this one. So you're really dealing with these IDs or with these entities of data structures. And then you can set values or delete values, whatever. What you should have in mind is that the data itself must be serialized. And there are some serializer here, but maybe you have to write your own serializer to fulfill the needs of this system. If you want to have a little bit more convenience, then you can go to the entity store. The entity store is dealing with entities or with documents and the link between documents. So you can really have a link. This document is linked to the next one and so on. Here's the same. You have one place on your hard disk to store your data, and then in every transaction isolated you just create a new entity with an ID or with a name, and then you're setting and getting properties that you have to do manually. Well, it's a document store. Another implementation is a virtual file system. The virtual file system is on top of the environment, not on top of the document store, and it's optimized for dealing with streams. So if you want to write down binary streams or blobs or whatever, so you have your data output stream, data input stream, and so on. And here you're just writing binaries. That's it. And again, transactional. These are the three choices you have as Xodus, and well, this, yeah, it's from the company JetBrains and is an active project. If you have to deal more with just writing data down once, you should have a look at Chronicle-Maps and Bytes. This is a project from Peter Lorre, and it's from the financial systems or banking systems, so writing down event streams or transaction logs or whatever. All these projects are available on GitHub from Peter Lorre here, OpenHFT, Chronicle-Bytes, Chronicle-Map, and Bytes is just writing down raw data. If you're very compact version, you can just write an int and byte and int and so on disk. And if you want to have a data structure, you should go to the map. And yeah, how to use it. You have here a dependency, for example, Chronicle-Bytes, and then you can just say what the way to allocate memory. It could be on heap, off heap, direct on disk. So this is what you should choose, and then you can just read and write raw data. Here's an example how to write it into a file, and that's it. So straightforward, quite easy, and very raw data. If you want to deal with maps, just add this dependency to your project, and then you have the possibility to create maps, and then you have to decide the type of the key and the value for this entity of a map. So every map you want to handle with is just with an ID, with a name, and there are some special things. You need to know your data very, very clearly, or you need to know how long and how many you have and all this stuff. So you have to say an average value. So if here in this example there's a string or a char sequence, the value inside this hash map, you should know how long the char sequence is in the average, because based on this the maps implementation will tune itself and will be efficient or not. And then you can just write down all this stuff to disk. The next project I want to show is a very interesting thing, because there is a feature that is unique somehow, and it's called MapDB. MapDB is on an open source project as well. It's written in Java and Kotlin. It's maintained by one person, and it will give you a drop-in replacement for maps, lists, queues, and other data structures. You have the choice with off-heap or on-heap implementations, but the good thing is you have transactions already based on MVCC on this, so you have really a commit and rollback functionality. But the unique feature is that you can make multi-level data structures out of it. So you can cascade maps, for example. And I will show you how to do this. First, you are adding the dependency, and then you create the place in file DB or in memory DB. Depends if you want to have it just in memory or you want to have it on disk. And then you're creating the instance of the data structure you want to use, so the entity of one map or one queue. And then you're just working on this instance here. This example is the map. I'm putting here two values, I'm committing it, now it's visible, I'm putting the next one, I have a rollback, and so on. So it's really a commit and rollback strategy here. Coming to the unique feature of MapDB. Here I'm creating two DBs. One is file-based and one is memory-based. from the file-based one, I'm creating a hash map, and everything I'm writing here will be written down after a commit immediately to disk. Or with a commit, it's written to disk. So the next thing is I'm creating for the in-memory representation a hash map, and here I can define with expire overflow the target where to write my stuff in. So I can write here everything that is evicted by the algorithm directly to disk. And with this I can start building up hierarchies, multi-level hierarchies, not only two levels, I can build different levels on here. And this is very unique because now I have a cache and it's written on disk. So, okay. The last thing I want to show you is a very young project. This young project is from a German company, and it's very, very convenient. Why? It will give you the possibility to store the whole graph you're creating in with your data classes without any needs in special inheritance or whatever. It will just store it. It can deal with cycles. So I wrote a few articles on DZone about MicroStream, and I try to tease it a little bit. So have a look there at these articles, and you will see what I have done to analyze a little bit MicroStream a longer time ago. One thing is it's not open source, but it's free to use, and it will help you just to write down your Java graphs. How to do it? They have their Nexus repository. If you have Artifactory, you can just use a remote repository here and then put this one in your virtual repository, so that's convenient to access. And then you have two dependencies, the embedded store. Maybe in the future they have external stores as well, but right now they're just dealing with embedded stores, and then some additional configuration stuff. They have some additional dependencies you can use. It depends a little bit what additional functionality you want to have. How to use it? You're just creating your class, you're adding your values, and you're setting your attributes, and then grabbing an instance of your embedded store, setting the value as root or as an attribute, and storing it. That's it. The main thing is everything to store in MicroStream must have a root. And the root should be a collection if you want to have more than one entity stored. So just take a map or set or list or whatever you want to have, and then just add your attribute there. You can just store your model as it is, so you don't have to modify it if you're just storing the whole model. The only weak point here is you don't have transactions. So this you have to do by yourself right now. And one thing is, if this graph is way too big for you, for your memory, then you can have something like partial graph loading, but it must be implemented with virtual proxies. And this is the only thing you should have in mind. You have to modify here your graph that you're adding this lazy references to your graph. Otherwise, cycles are not a challenge and no need to have special inheritance or whatever. So this is a very convenient thing. If you need transactions, I personally would have a look at MVCC, this core implementation I showed you in the beginning, and would add this one on top of MicroStream so that you have the convenience of storing without mapping your model and transactions in the same way. So this is really a unique thing. But production, what should you have in mind if you're going to production with all this stuff? Typically, or sometimes you have this traditional way of organizing. So you have your devs, they're implementing stuff, and if it is implemented, they're pushing it to a repository, maybe something like Artifactory. And then the ops part is grabbing this binary, configuring, testing it and all this, and pushing it to production. But before, or if you want to decide what's the right persistence layer for you, you should have an eye on transitive dependencies to make sure that the compliance stuff is not kicking back someday, and that you know what if there are some security issues, yes or no. It means if you're going more to the DevSecOps part, and it's necessary that you don't have some dedicated place where it will be checked or regulated. It should be everywhere in your pipeline. So here I'm just giving you a few ideas about check for the keyword security first culture, and how to implement this one. I have some tutorials about DevSecOps, so if you want to have an intro there, just check my YouTube channel. You will find there an introduction to DevSecOps. But the key point here I want to highlight is that all this compliance and security check must be as early as possible. So if you're writing the first line of code to explore the possibilities of these persistent layers, it's just adding a dependency to Maven. You should have all information about compliance and security if there's something available. So random thoughts. So I personally think that if you have a small amount of components, you have less components that can fail. That's not this is not new, but just have it in mind. So if I can get rid of different operating systems, different components that must be ramped up and down, then it's mostly less that could fail. And if you are going test driven, so if you want to have a bunch of tests and I want to have my persistence layer tested as well, that makes sense. Shorter ramp up and ramp down times are really helpful. So for example, if you're dealing with Postgre, you have this open source project called test containers, and it's ramping up your database really in seconds inside Docker, and you can provision it, you can deal with it, you can write your tests. But a few seconds is a long time compared to an embedded store that you can ramp up just in a few microseconds or milliseconds. So one thing is data migration. Well, this really depends on the system you want to have. So how to migrate not only from system A to system B, but have in mind that you have something like migration between versions of a system. So how to deal with this one, this really should be checked before. But if you're dealing with one of these four I showed you here, systems, then you have the possibility just to store a binary file, for example in Artifactory, in generic repository. And if you're testing, just you have to get this binary store or this binary file, you have to load it, and then your system is provisioned for your test. So you have immutable data, test data sets in a central place. So this is perfect. Compliance and security issues. Check all components. Some of these projects I showed you here have a lot of transitive dependencies, and one of their system has right now a security issue. So just check it, what's going on and how fast and this will be changed, or if this is a challenge for you. And this is more or less some basic ideas about this one. The good thing is all these systems are just a dependency in Maven, so you can just add it and use it immediately, and you have code completion, regular code completion, so you don't need a special plugin or whatever. But all the systems have some weak points in terms of tooling. So ad hoc queries or navigation through the data, there is no really tool support. So you have to have this one in mind if you need something and what exactly you need. Maybe you have to write it by yourself. Backup and restore is quite easy because it's just copy and pasting a file, that's it. My personal view are about pros and cons of these systems. If you have a document store, you should definitely go to Oxodus. This is a very good thing. JetBrains is a cool company. They have good engineers and they are maintaining this actively. So this is really good. But only if you really have to deal with document-oriented storage. Otherwise, you are just mapping way too much. Chronicle itself, you can buy support. That's good. But for me, I think it makes just sense if you want to write down data as fast as possible with a low latency, and that's it. It's not good to navigate through the data and modifying all this stuff. Just write it down. That's it. MapDB, if you need hierarchies, hot data memory and something on this is really a nice system. But The version 3 is quite old. If you can use it and you have no issues with this, just go for it and do it. But it's a one-man show. This is the only weak point of this project. So if there's something like a bug fix or you need some new features, it could take some time. Have this in mind. If you don't want to map data and you really want just storing your graph, the convenience way to go these days is MicroStream, because MicroStream gives you exactly the possibility just to hold your graph, store it, and that's it. So navigating is just through streams or imperative with Java. So you don't have to learn a different language, you don't have to map your data, you can just store it and read it and manipulate it. So this is very convenient. But you have no transactional behavior there, so you really have to have a look if you need transactional behavior, and if yes, maybe have a look at MVCC. So this was more or less all about these systems I want to show you. If you want to try this, I created a repository on GitHub with all these dependencies so that you can compare the systems and you can analyze it. To analyze the security situation and the compliance situation, the easiest way to do is right now go to JFrog, this URL I showed you here, start a trial in the cloud. It will take 10 or 15 minutes for you to ramp up a whole structure, and then go for it and analyze your project. Here, what you should do, go to the URL and start a trial. From this, create a remote Maven repository. How to do this? I have a tutorial about this as well. It's just a few minutes. And then you can go to the GitHub repository, clone the repo, and change the attribute for the repository so that everything is loaded over the Artifactory, and with this, it's scanned with X-Ray. If you want to know more about X-Ray, how to create this report and how to analyze this project, just ping me or check out my other tutorials about X-Ray. And yeah, here are all the URLs for the different projects I used here in this example. I will add my slides as link down to inside the description to this video. And so far, I would say thank you very much for attending my talk. If you have any questions, just ping me via Twitter or write an email. I would really appreciate if you would give me a thumbs up, or that you, just, what's the right name? Yeah, go regularly to my channel. And, well, feedback is welcome, and have fun. See you.